Welcome back to distributions. So in this problem, we're looking at extremes. In other words, we're looking at both sides of the distribution, looking left and looking right. So the first problem is extreme temps. Find the probability. The lifeguard staff at Lake Winford tracks water temperature throughout the summer to help schedule breaks. Daily temperatures follow a normal distribution of a mean of 78 and a standard deviation of 4. A day is considered unusually cold if the water is below 70 and unusually hot if it's above 86. What's the probability that a randomly selected summer day at Lake Winford is either unusually cold or unusually hot? So the case, we're going to be looking left and right. So we're looking at both sides, two sides. So for the extreme low, which is this line, we'll be looking at the left. The mean is 78, variability is 4. The raw value is 70 for cold water. And the z-score is x minus mu divided by the standard deviation. Probability is norm dot s dot dist of the z-score, true. So 2.3% of the days have cold water. Now let's see what percent of the days have hot water. So this is going to be 2, but looking right. The population mean is the same 78, but we don't want to type it, we just want to reference it. Same with the expected variability, just reference it. The raw value from the problem is 86, is what defines a hot day. And the z-score is going to be x minus mu divided by standard deviation. And the probability is going to be equal to 1 minus norm dot s dot dist. And it's 1 minus because we're looking right. Okay, so we get 2.3% over here, 2.3% over here. And those are the extreme cold and extreme warm. How many degrees is the standard deviation? It's 4, then we'll reference it. How many degrees is mu? 78, reference it. If there's 100 days of summer, how many are extreme? So it's 2.3 plus 2.3 would be 4.6, but we're supposed to round up, so it'll be 5. What percentage of days are between 70 and 86? Now this is now looking at the empirical rule. It's empirical rule, there's 70, there's 86. So if you look just at the empirical rule percentages, it's going to be 68 plus 13.5 plus 13.5 is 27, so it's going to be 95. Effectively 2 standard deviations. And kind of amazing how that came out. Just the same, right? So the precise calculation is about the same as the empirical rule. What percentage days are less than 70 degrees? So that would be over here. And that would have been 2.5%. When we were more precise, it was 2.3, but empirical rule is pretty darn close. All right, reference cells in the formulas to answer what percentage of days are less than 70. So that equals the 2.3. Now we're being precise. More than 80, then 86. That says 96, but it should say 86. I'll fix that before distributing it. 2.3. And what's the probability that a randomly selected day is unusually hot or unusually cold? We would just add these two together. Equals this plus this. This is being precise. So 4.6, or rounded up, it was 5 over here. Okay. So, next problem. battery life. And here we're going to be given the probabilities and asked to find X. A tech company tests the battery life of a new tablet model. The battery life follows a normal distribution of a mean 11 and a standard deviation of 1.5. Each tablet is tested while running continuous video playback, though customers typically use the device for mixed tasks. What is the range of battery life that excludes the lowest and highest 10% of devices? So we're going to have an extreme low and an extreme high again. So we can have a 2 left. The mean is 11. Standard deviation is 1.5. The raw value is what we're looking for. We don't know it, but we are given the probability because we want the lowest 10% and the highest 10%. So we have to work backwards to a z-score, which is norm.s.inverse of the probability, negative 1.28, and then the raw value is z times standard deviation plus mu. So 9.1. So 9.1 hours in this case. All right, and then we've got 2 looking right. Population mean is going to be the same, so we can just reference it. Variability is going to be the same. We can reference it. The raw value is what we're looking for. We're also given the percent here is also 10%. And we can do the, all right, now we'd like to do norm.s.inverse, but it's not the probability, it's 1 minus since we're looking the other way. And then the X value is going to be the z-score times standard deviation plus mu, 12.9. Okay. So we're somewhere between 9.1 hours and 12.9 hours if we exclude the extreme values, which is what the problem wanted. So reference the low temp for the middle percentage. So the middle percentage would be between these 2 extremes. What would the low, well, this says temp, but it should be low time. I'll fix that before I distribute it. A lot of things to fix here. And the low one is the 9.1, so equals. And the high one is the 12.9. What percentage does the middle portion represent? Type it. So, well, if that's 10 and that's 10, that's 20. So what's left is 80. And we're all set. And we're all done with the exercise. And congratulations.